Check with the neighbors, see what they got. To call one person to help us out with this. Okay. I'd like to hear your thoughts. Kara, what do you think? How do you find the zeros for this? What's that? The prime, is that what you said? Are we good? So we didn't need to do p's over q's or anything like this? That for this one? No, for quadratic, your first order of business should be to look and see if it can be factored. And I think pretty quickly you see, nope. Parents, that kind of would cross your mind first. Like super quick, that just comes off your list. So then you have two choices, either quadratic formula or complete the square. And complete the square here is definitely not ideal because because there would be a fraction that comes from the fact that 5 is odd. It's a little cumbersome. So I agree with that. The way to do this would be quadratic formula. Thank you for your help with this, by the way. Yes. Well, one of the graphs. Okay, from the homework or okay.
Staggered minimum. How do you know which one is the lower one? Yeah.
Something like this. You would either need a calculator or an accurate graph, but we don't have any sort of like algebra that you could use to get that minimum right now. It would be outside of the scope of today's quiz for sure. So this is not something to worry about. But it's a good point. Both of these points are called relative minimums. Oh, yeah, and this bottom one is called an absolute minimum. But we're not looking for those things. And our goal right now is about the zeros. But thank you, good question. And of course, if we were to write these answers that Kara so eloquently gave us separately, we do recognize that these are two distinct answers, correct? One is -5 plus square root of 17 over 2, and the other one is -5 minus square root of 17 over 2. And I could further break this up using, by pulling a Moses, excuse me, right? 5 over 2 plus, remember that? And -5 halves minus root 17 over 2. What's the relationship between the vocabulary word that I'd like to know that would describe the relationship between these two answers? Can you quietly check to see with your neighbor and then I'll get your question just a second. There's a vocabulary word. You see what it starts with? The vocabulary word starts with, it starts with a C. Don't have to mind just what it is. Does that make sense that these are conjugates? Or the conjugate of A plus B is A minus B. So these are conjugates. Oh, is that what we have? Yeah. Oh, this is the last one is what I wanted in. If there's an I involved, it doesn't mean complex. Yeah. This is fine. Yeah, this is fine. Good question. Thank you. Yeah. You may stop right here. Stop is okay. I was just kind of extending it so we can have that vocabulary in the front of our brain for today. But I would think it's possible that we can see that they're counting this in that point, so we don't need to go all the way to that end. Um, let's do it. Let's keep going. All right, let's focus up at the front. Let's focus. The packets. Let's finish this up. I feel like all the skills we did last time were not practiced in the homework, were they? Or were they? I guess you had to find all the roots for a couple of them, didn't you? There's mostly lists, if I remember correctly. Mostly zeros.
There's some of it. There's some.
So you did have to find the zeros. Okay, good. Okay, cool. What's that? Uh, oh, really? Oh, because square root of something silly.
Yes.
I don't know if I like that. But it's good to remember that these numbers do have value that are a little bit easier to relate to. Oh, before I forget about relating, can you just discuss that with your neighbor? How would you do that date? How do you find the coordinate of that midpoint? So this is 87, 87. Are you drawing it out and putting lots of tick marks? That's one way to do it. Or just take the two numbers and find the average. Results in a 5, I believe. Okay. And though that has nothing to do with today's lesson. Let's do this one first. The fundamental theorem of algebra. Seems kind of big, doesn't it? I don't want to get this wrong, so I'm going to copy this from the book. If f of x is a polynomial of degree n, where n is greater than or equal to 1, then the equation equation f of x equals 0, which means we're saying that polynomial is equal to 0, has at least one complex theorem of algebra to be a little bit more mind-blowing. We're saying if you have a polynomial equation, it's going to have, and then we set it equal to 0, it's going to have an answer. The answer is going to be complex. Is the number 5 complex? It is. It's a complex number with only a real part. Complex is a plus bi, but you don't have to have both of them. Yes. There are. I would think maybe the fourth root of the -1. I don't think that's complex because that doesn't work out to be I, but I don't know what it is. But the numbers that we talked about in this class are all complex, every single one. And I think in general, in mathematics, that's what it's going to be. In fact, the fourth root of -1 could probably be broken down into complex number. I just don't know what it is off the top of my head. I'd say that this is fairly useless compared to the two properties we're going to talk about. So the first one, I'm going to get this one here. of a polynomial equation is of degree n, then the equation has n roots. I don't do multiplicity. This is the important one. I refer to this quite often. In other words, a cubic polynomial equation will have 3 roots. And they could all be the same. It could have multiplicity of 3, but it will have 3. And number 2, if a plus bi is a root of a polynomial equation, then a minus bi is also a root. In other words, imaginary roots exist in conjugate pairs. We'll use this as we continue in the section today. Both of these, so they're pretty important. Excuse my bad handwriting. Can you read it? Find the fourth degree polynomial function with real coefficients. Yeah, that is one of the properties. The polynomials has to have real coefficients. You can't have imaginary coefficients. That has real coefficients that have -2, 2, and I as 0, such that f of 3 equals -150. We now know that the zeros are -2, 2, I, and -I. That's 0 plus I and 0 minus I. They come in conjugate pairs, so there's an imaginary portion. So we're looking for the function. Has anyone seen it? Just kidding. So we have f of x equals this -2. That means one of the factors is going to be x plus 2. The other one's going to be x minus 2. The other one's going to be x minus I and x plus I. Yes. Zero. Yeah, sure. But I don't want to see any imaginary portions of this. So yeah, let's multiply out the last two. Actually, let's multiply out what's easy. Like those first two factors are pretty easy to multiply out, aren't they? Let's do it. So notice I did leave a space. It's -4. And would you please just check with your neighbor what are those last two factors multiplied out? Neighbor, what are those last two factors when you multiply them out? Just the last two factors. Yeah. At least what are those last two factors multiplied out? Let's just kind of let's not overthink it. The first one is x squared minus 4, isn't it? A squared minus b squared. So this is just x squared minus I squared, correct? And I squared is -1, which is why this becomes x squared plus 1. Is that where you're thinking and just where you're second guessing yourself or something? Okay, good. Yeah, that's what it is when you multiply these out. Now, notice it does say to find a zero such that f of -3 is equal to -150. If we plug in a 3 into this function, do we get -150 as an output? We do not. So in order to fix this, what I'm going to do is I'm going to introduce something that won't mess with the factors. In other words, I'm going to introduce a leading coefficient. I'll call it A. Now when I plug in my f of 3, I keep that A. I keep all the factors. What is this? 9 minus 4. This becomes 9 plus 1, which equals -150. Times A equals -150. I just found out. Did I do this right? I just found out that A equals -3. Is that the answer to my question? No, the question is to find a polynomial for which all this stuff is true. So my answer is a polynomial. So my answer is actually f of x equals -3 times x squared minus 4 times x squared plus 1. You could multiply that out if you want to, but it's okay to leave it in factored form as long as I don't see any imaginary numbers. Any questions? You're going to be done by the fourth degree, coefficients are this, so I'm going to three in there. The zeros are these three, so we know that these four are zeros. It might there be more zeros. But fourth degree, so it only has 4 zeros. Another property of the following. Here and there, these are all the factors. This is an A that does not affect the factor. Multiply out any of the conjugates. Simplify it by the order. Plug in the 3. To figure out the A of -3, and here's that function. All the way. Oh, you have a question? And again, you may leave your answer in factored form as long as I don't see any imaginary numbers. So third degree polynomial, real coefficients 4 and 2i as zeros. I'll give you a moment to work on this. And check with your neighbor once you get the answer. Or if you're stuck, of course, check with your neighbor. Are we ready? Better not. I'd like to see what you got. Charlotte, what'd you do here? Okay. We're good with this, everybody? Perfect. Three times five. Is it? Oh, yeah, it's five. Okay. Thank you. Equals -50. Okay. Are we good? You could multiply that out if you want to, but it's perfectly fine in factored form. Multiplying it out would be two things. One, a waste of time, and two, dangerous. Because if you make a mistake from there, it's really sad. So thank you for your guidance. That's perfect. Okay, determine the equation of a polynomial function that might have the given graph. More than one answer may be possible. Uh-huh. I think you could do this already. But yeah, definitely discuss that A if you haven't already. Okay. So let's see if this is what you did. We know that the zeros are 0, 1, and 2, correct? So my function is obviously x minus 0, x minus 1 times x minus 2. Now there's no indicator of a y value here. It doesn't appear to care that there's a y value. I'm going to change the x minus 0 to just x. Then I'll just move all of this over here. Okay, done. Any questions? At least? Is this true? X minus 1 should be squared? Okay, either squared or to the 4th power or to the 6th power, but let's not be crazy. Always keep the least amount. Yeah, so there's a problem that it doesn't match that touch, but also if you leave your answer like that, the problem would be that the end behavior is completely wrong, isn't it? We've written a cubic. It doesn't match. In order to match, we have to recognize that it's touched, which gives us a multiplicity of 2. And now we do have the 4 zeros because the zeros include, the counting includes multiplicity. This one, are we going to have that same problem? No, we do not. We have, I'll go right to it. F of x is equal to, I notice I'm going to leave a space here. X plus 1, x minus 1, and x minus 2. I've left a space here because the difference between this graph and the last graph is that we care about one of the y values. Now, by the way, we do kind of care about the y value. What if this were all flipped over? Then you just have to make negative, but we don't care specifically, but we do want the behavior to be the same. And here we do care that the y-intercept is -1. So what do? I put an A right here to control that vertical stretch. And now we plug in our number. Specifically, we're going to plug in a -1. Is that what we're plugging in? No, the coordinates here are 0, -1. So we're going to plug in 0, and then the output has to be -1. Is it a surprise that our answer is negative? Not a surprise. Is it a surprise that it's 1/2? I didn't foresee it, but it's not like, what? Should I multiply out the conjugate pairs? If you want, you may. I think it would be a little bit more efficient in terms of writing. I'm going to just say that this is perfectly fine. Any multiplication you do from here is up to you. But this is 100% points is what you get for this answer. Unless the question says to multiply any conjugate pairs. Moving on. What? Not moving on? We got to do one more. This has not been satisfying. Okay, function. I hope you have some room. If you don't have room, maybe just do a different paper. With zeros, 5 and 4 minus 3i. Let's do one that's worthy of your intellect here. I want the function with these two. Smallest degree possible. Or do you want to do 4th degree? I like it. Let's do fourth degree. Thanks. That's a good idea. Fourth degree. And do you see quickly that's going to be a little bit of a mess? I'd like to help you with this mess if you don't mind. Because automatically you're like, okay, I know this is a 5, this is 4, minus 3i, and it's 4 plus 3i. These complex numbers with imaginary parts always come in conjugate pairs. As long as the coefficients are real. Okay, so now you're like, if you're trying to go through the same thing, x minus 5. What do you do to this x minus 5 since we want it to be a fourth degree? You just put a 2 on it, right? It's no big deal. And then you're like, this is about to get really messy. Did that go through your head? That this is just kind of, there's a lot of, seriously? He's gonna make us do this? X minus 4 plus 3i. Now, although this is true, you can see that, is this answer fine? No, I don't want to see any imaginary parts. This would be like a B minus answer. This is good. Maybe a B answer. I know you all want that 100% answer though. So you have the choice of actually multiplying that out, which probably leaves you with a feeling, or I'm going to show you a trick on how to get the factors that have those two zeros quickly. Do you know the trick already to get that? What I'm saying is, eventually we know it's going to be this. We want to have a nice, clean quadratic polynomial in the empty parentheses. To get that, I'm going to use the fact that we're dealing with zeros here. So I'm going to say that x is equal to 4 plus or minus 3i. Just like with that 5, I could say that x is equal to 5, right? And then from there, I could say that x minus 5 is a factor. That's a factor. So I'm starting with the 0, so x is equal to those zeros. And I'm going to clean this up a little bit by isolating the term with I. And go ahead and put your pencils down now. For now. Just watch. Just enjoy the show here. Okay, so now I have this. I'm going to get rid of that I by doing what to both sides? Squaring both sides. So we have x squared minus 8x plus 16. You were thinking that, weren't you? Now, when you square 3i, you get, let's see, when you square 3i, you get -9. And when you square negative 3i, what do you get? It's also, well, isn't it -9? So when I square this, right, because I'm squaring both sides, when I square this, I'm going to get -9. I want to set that equal to 0, so I'll move that 9 over. Plus 25 equals 0, yeah? Done. X squared minus 8x plus 25. There's my other one. So rather than multiply those two huge quantities out, I recommend just start the x equals that complex portion, isolate the imaginary part, square both sides, that equals 0, and that's exactly it. How do I, well, let's solve this last thing. I'm going to solve that by completing the square. X squared minus 8x equals negative 25. Add what to both sides? 16. This is seeming familiar to me. And then we have x minus 4 squared equals negative. This seems so familiar to me. And x minus 4 equals plus or minus 3i. Yep. The roots are exactly what I want them to be. At the 4 plus or minus 3i. It was. So that is the word for it. Hope it makes sense. Yes. Good question. Yeah, well, this has 2 weeks. You know that I polynomial of 2 degrees have 2 weeks. You know, they are here. So we have 1, 2, 3, 4. So on the 5th degree, I make that x minus 5 to the 3rd power. Counting up to 5. Oh, good question. If we square the second one, then we have a polynomial that is how many degrees? How many? 4. Right now the polynomial is 5th degree, isn't it? That's x squared means squared. That's the 4th. So if it's asking for 5th degree, that's the one either square than or cube degree. Yeah, well. Yeah, we like it, but it doesn't affect it. Would it read or does it read? Yes. Oh, if you like made up your own roots? That's interesting. If you just 4th degree and like you didn't say anything about other roots, so you just put this in there or something. It didn't go against what's saying, right? This it says it has those zeros. But the assumption should be there are no others. Except the hints of this thing. But it's sneaky. I'd have to word it. Yeah, it seems like you could, if I marked it wrong, you come back and say you didn't say there were other zeros or something like that. The creative other solution. Me gusta mucho. Okay, we're gonna start in about 3 minutes. But before that, you could relax, stretch, zone out.
For like compression or work, if I set up this event division like this, because then it's just like if I want to test out someone else, I can drag down and do 2 or something. That's about okay. And then also, if it doesn't say to like list out like the multiplicity system, do you have to like do the layer?
You have to be in your head if you want. Is that what you mean?
Yeah.
Yeah.
This is the. So if I get back in similar would just be I don't think I need to talk about it for lots of context, right? That's not
More, it just ugly. So if you can put that formula, you want x plus the first one. I said x minus the first one, that was the second one. You don't have to read about that today. So your quiz is on my math lab. Could be done on my math lab. I'm gonna want to see your work to make sure it's shown clearly on paper somewhere. But you can start whenever you like. So it's ready for you. I hope your laptops are charged. You're okay. What's that? Oh, I have paper. Is that what you mean? No. Do I want you else to take it? Grab more, right? Okay. Should be available. Do you see it? Because I don't see it. Okay.